Hello, ladies and gentlemen. Welcome back. We are starting chapter 3. We are going to be looking at examining relationships. This is the scatter plot chapter where we have our x and y axis and correlation and least squares regression line and all of those good things. All right, so we're going to go ahead and get started here. First thing I want to point out is that on Schoology, ladies and gentlemen, at any time, if you get stuck, there is a how to do scatter plots on the graphing calculator. You're going to need to know that really well. So if for some reason you get stuck, there is a video out there that you can go and look at. That it is me that I made a couple of years ago. Looking at the calendar, ladies and gentlemen, you can see that Chapter 3.1 is on October 20th, Chapter 3.2 on Thursday the 22nd, and then 3.2 again, and then 3.3. And yes, we're going to have a project in this one. I'm going to give you obviously plenty of time to do that, and then our next test is in November 3rd, ladies and gentlemen. All right, and then we'll begin Chapter 4 November 5th. Okay, enough of that. Let's keep rolling here. So I'm going to apologize. This video is probably going to be longer than I want it to be. I like to keep it about 15 to 20 minutes, but I have a feeling this one's going to be longer. There's a lot of stuff that I have to go over with you, and there's stuff with the calculator I'm going to do. So remember, you have the power of pause and rewind. All right, here we go, ladies and gentlemen. So first thing is to get my pen to work. There we go. All right. So we're going to be dealing with our x and y axis. All right. Except we're not going to call it the x and y axis in AP statistics. The x-axis, that is going to be called the explanatory variable, ladies and gentlemen. The y-axis is called the response variable. So the data that goes on the x-axis, the numbers, that's going to explain what the response is. All right, so remember that. The x-axis is the explanatory. Here's one way to remember it. The explanatory has an x in it, and that goes on the x-axis. All right, and then the response is the y. So what are some things we need to remember? Okay, this goes back to advanced algebra because we did briefly talk about some of this stuff. All right, so we know, remember, these are scatter plots, and that means the dots are not going to be in a perfectly straight line. Okay, they're going to be scattered. They're either going to be scattered close together or they're going to be scattered further apart. That's where the correlation comes in, and we'll get to those details in a little bit, and having the calculator do that. All right, now these dots are obviously rising. So this is a positive correlation. All right. Okay, moving on. So I think you know what's coming next, right? If the dots are going down, falling, that is a negative correlation. If the dots are all over the place and you can't tell the pattern, okay, you can't tell if they're rising, you can't tell if they're falling, then we say that there is no correlation. All right. What else do we need? Well, one thing you need to remember for a positive correlation as the explanatory variable increases, the response variable increases. Sorry if my handwriting is sloppy. Writing it up on the screen like this is a little bit more challenging. I'm getting better, but it's not the best. Now, I could also say as the explanatory variable decreases, the response variable decreases. So I could go backwards. But remember, positive correlation, they both are doing the same thing. The response and the explanatory do the same thing. As one goes up, the other goes up. For a negative correlation, as the explanatory variable increases, the response variable decreases. Okay, they do the opposite. Negative correlation, they do the opposite. As one goes up, the other goes down. Okay, they do the opposite. Now, what else about correlation do we need? Okay, we're going to get a lot more detail than we did in advanced algebra, folks. All right, so first of all, correlation. And when we talk about correlation, we use the lowercase letter r. And that's what the calculator uses too, and I'll be showing that to you. Okay, correlation tells us two things. One tells us, here, let me write that out, tells us two things. One, it tells us if it is, not if is. Okay, come on, you silly thing. Is it stuck? All right, there, we're going to do this. It tells us if it is positive or negative. Okay, so obviously if the number is positive, the dots are rising. If the correlation is negative, the dots are falling. Two, it tells us the strength of the relationship. Between the, I'm going to abbreviate here, between the explanatory and response variable. So it tells us direction, and it tells us how strong or how weak it could be that relationship is. All right? Again, look in your book, read your book, look at Khan Academy. There's stuff in there that'll help you if you don't quite get what I'm telling you here. All right, now I'm going to go through some examples of this. All right, well, first of all, correlation is a number from -1 to +1. No labels. You cannot have labels on a correlation like inches. No labels. Nothing. Okay, it's just a number that tells us those two things. All right, well, first of all, for it to be a perfect -1, the dots would be in a perfectly straight line decreasing. Okay? To be a positive R of 1, the dots would have to be in a perfectly straight line increasing. Okay, they just have to be in a straight line, perfectly straight. And for a correlation of 0, you can't tell. You can't tell if they're going up or if they're going down. Okay, because there is no relationship there. Okay, obviously this is the weakest. Now, as far as the -1 and the +1 goes, okay, they are equal in strength. Again, let me repeat that. I can't spell. Okay, they are equal in strength. I think I spelled that right. Okay, it's just one, the dots are going down, and the other, the dots are going up, but they're equal in strength. Those are the strongest. Okay, those are the strongest correlations you can have. Now, just some general idea here, like if I had R equals -0.9, that means the dots are going down and they're pretty close together. Okay, compared to like R equals -0.7, then the dots are going to be a little further apart. Okay, and as they get further apart, they get closer and closer to 0. Same thing with the positive. Okay, if the dots are fairly close together rising, then that R, okay, that might be like a 0.9. And the further apart they get, the closer they get to 0. And we have a way of actually measuring those kind of things with the calculator. The calculator will do that. But you have to have an idea of what those scatter plots, what those dots look like. All right, so to interpret scatter plots, look for a pattern and any important deviations from those patterns. Remember, if I'm going too fast, you have the power of pause and rewind. Interpreting a scatter plot. In any graph of data, look for the overall pattern and for striking deviations from that pattern. You can describe the overall pattern of a scatter plot by the direction, form, and strength. All right? An important kind of deviation is an outlier, an individual value that falls outside the overall pattern of the relationship. Now, there's this formula to find the correlation, and you're like, oh my goodness, okay, we're never going to have to use it. In the 15 plus years that I've been teaching AP stats, we've never used it, okay? But that's what it looks like. And if you want to research that and see what it means, please feel free, all right? We are going to use bits and pieces of that for other stuff later, though, all right? So I'm not going to take time to go through that. So we're going to find some correlation here, all right? So some R values. So I'm going to take a moment. I'm going to pause the video for myself, and I'm going to enter this data so I don't take up too much time. So I'm going to enter this data into the calculator. So I'm just going to pause and enter, so I'm going to come back like almost immediately for you. All right, I'm back. So what I did was I typed these numbers into list 1 and list 2 on my calculator. Speed goes in list 1, and don't forget the 2 that are over here. And the fuel used goes in list number 2. Now, I'm going to have the calculator tell me the strength of that relationship. The speed explains the amount of gas used. Think about it. Your speed explains the response, which is the amount of gas used. Now, before we do that, though, I do have to do this with the calculator, so pay attention. So you got to go second, and then go to the 0, which is the catalog, everybody. All right, then you're going to scroll down to diagnostic on. Okay, so you need to scroll down to the D's and go to diagnostic on. If you don't turn this on, the calculator cannot tell you the correlation. So diagnostic on, I'm going to hit enter twice, and now it's on. Okay, if you need to, rewatch how I did that. Again, second, 0, which is the catalog, scroll down to diagnostic on. Okay, so now, ladies and gentlemen, we're going to go stat, calculate. Now, we're not going to do number 4, linear regression. We're not going to do number 4. That's for like advanced algebra and students who are not AP Stats. We are going to go down to number 8. Okay, notice the slight difference. It's a plus bx. So that is the one we want to use, is number 8. Now, all we care about today is the correlation. We don't care about anything else. So I'm going to click until I get this. So right here, the very last line, don't worry about what's up above. Look at the very last line, and we're gonna talk about all of these things in this chapter, but today we're just looking here. So negative 0.9, I'm gonna round 2 decimals, negative 0.91. So this correlation is negative 0.91. That is a pretty strong relationship because that's close to -1. So actually, I'm gonna write this is a very strong relationship. Your speed definitely determines the amount of fuel you are using when you drive. Okay, let us continue. Okay, I'm going to pause the video again, and I'm going to type this information in. I'm going to put temperature low in list 1 and the number of hot cereal sales. So let's think about this. The temperature outside, do you think that affects how much hot cereal, like oatmeal, how much it affects sales? I believe it does. The day, we don't care about the day. All right, so I'm going to pause and I'll be right back. And just like magic, there we go, folks. All right, hopefully I didn't make a mistake typing these in the list 1 and list 2. I've already got my diagnostic turned on. I don't have to do it again, so I just need to go stat calculate. Number 8, you don't have to scroll there. Just go ahead and pick number 8 and then hit enter. Make sure it says list 1 and list 2, and then voila. Okay, so I see that the correlation is negative 0.80. Negative 0.80. Okay, that is a strong relationship, but it's not as strong as that last one. Okay, it's a little bit weaker, but it's still strong. In the 0.8s, it's strong. Okay, even the 0.7s are strong. All right. So the same thing with this one. The year in use, accidents, fatalities. Okay, I'm going to ignore these two, and I just want to see, well, what type of relationship is there between accidents and fatalities? It could be car accidents, it could be boat accidents, whatever. All right, so again, I'm going to go ahead and pause and put that data in, and we'll take a look at that. Again, I've got the numbers typed in. Here we go. I'm going to go stat calculate number 8, and let's see, how strong is this relationship? Obviously it should be pretty strong, shouldn't it? Accidents and fatalities. Okay, so ooh, very, very strong. Now this one's a positive. Okay, I can tell the dots are rising, so that correlation is 0.96. Let's go back to these other ones. So this one here, the first one, you notice it's negative, so I know the dots are falling. Okay, this one, the same thing, the dots are falling. Think about it. The warmer it gets outside, as the temperature increases, the hot cereal sales will decrease. Okay, negative, dots are falling. This one, the dots are rising or going up, because as the more accidents occur, the more fatalities there are, and that is very strong. That is a very strong relationship. Okay, again, the closer you get to 0, the weaker it is. The closer you get to 1 or -1, the stronger it is. All right, so here is a little matching game, or not a game, but a little matching here. So it's kind of hard to do, but I'm gonna go ahead and I'm gonna make this a little bit smaller so that we can see the whole thing. And I'm sorry if this is really small on your screen. All right, so see if I can make it just a little bit bigger. Yeah, that works. Okay. So I noticed right away that 3 and 7 are perfectly straight. Okay. Well, we know that the 3 is a perfectly -1 correlation. So that's going to go, so B is going to go with that. All right. The 7 is perfectly positive. So that has to be the A. Now, I notice that there's 1 in there that I can't tell the pattern. Okay, that's number 4, right? I can't tell the pattern, so that's going to be this one. Right, now I've got 3 positives and 3 negatives. Okay, I'm going to start with number 6. Those are pretty close together, so that's going to be a pretty strong relationship. So I'm going to look at the 3 available positives, which is 0.8, 0.6, and 0.2. Well, since number 6, they're closer together than the other 2 that are positive, obviously that's going to be D, 0.8. Okay, now I'm going to look at number 2 and number 5. Number 2, the dots are closer together than number 5. So looking at the 2, the F and the H, the F is closer to 1, which means it's a little stronger, so that means this one is F, and then this one is the H. Okay, then my 3 negatives. Again, the strongest negative is the 1, so that has to go with, okay, there's 3 remaining. That has to go with the -0.8, so that's the E. And then the next strongest one would be the 9, because they're not quite as spread out as the 8, so that has to be the G. And then the last one obviously is the J. Okay, pretty straightforward. All right, next. Analyze the 3 graphs below. The first graph is the original, and the other 2 have had a point added to them. Okay, let me blow this up a little bit bigger. So what do you think the new point will do to the correlation of each? Okay, folks, well, this new dot right here is going to make the correlation stronger. Because it's in line with the other dots. That means the R is going to be, we're just going to say the R is going to be bigger than 0.8. We don't know what exactly it is. All right. So obviously this one over here, this one, okay, now both of these are outliers, but look at where this dot is in relationship to that other one. It is not in the pattern. So it's going to make the correlation weaker. And obviously the R is going to be less than 0.8. We don't know exactly what it's going to be. All right. Okay. Now, in this problem, this is kind of interesting, and I'm going to be pausing and putting these in as I go. So I've got 9 dots here, and so I'm going to color code these. So this, like 1, 4, I'm going to put that dot in there as a 10th dot. Now the correlation of these 9 dots, okay, the correlation of the 9 dots that are on the screen is 0.71. Okay, that's a strong relationship. Now, if I add in the 1, 4, okay, so over 1, up 4, 1, 2, 3, 4, that dot would be right there. So that means there would be 2 dots of 1, 4. Okay, so what I'm going to do, ladies and gentlemen, is I'm going to type in Okay, well, hold on here. So these are the 9 dots that are there. Okay, so there's the 1, 4, and then the 1, 5, and so on. So those are the 9 dots that are on the screen. Okay, so what we're going to do now is we're going to add a 10th point. My apologies for what I said before. Okay, I'm not going to reshoot this video because I'm already 25 minutes in. So those are the 9 dots that are on the screen. So what I'm going to do is I'm going to add, okay, and I'll do this one in blue. I'm going to add, or green, I'm going to add 3, 7 to the mix. So let me get rid of this red here that I put on the screen. And let me get my eraser and take that off. There we go. All right, so now let's put this green 3, 7 on there. So over 3, 1, 2, 3, up 7, 1, 2, 3, 4, 5, 6. So that would actually go on top of that dot. Okay, so what I'm going to do, ladies and gentlemen, I'm going to take a moment and I'm going to put in my list the X values of these 9 dots. So the X values are 1, 1, 1, 2, 2, 2, 3, 3, 3. And I'm going to put in the Y values in my list too. 4, 5, 6, 5, 6, 7, 6, 7, 8. Okay, I'm going to pause while I do that and then I'll show you on the calculator. All right, so what I did was, again, I put the X values in list 1, 1, 1, 1, 2, 2, 2, 3, 3, 3. And then I put the Y values in my list 2, 4, 5, 6, 5, 6, 7, 7, 6, 7, 8. All right, so what I'm going to do now is I'm going to add to the bottom of that list, I'm going to add in this extra 3, 7. Okay, 3, 7. All right, now I'm going to go ahead and I'm going to actually draw this scatter plot. So, because I haven't shown you that yet. So remember to turn your scatter plot on. You hit second Y equals. Okay, pick number 1, and I'm going to go down, and the very first one is your scatter plot. Again, that very first box, that very first one is your scatter plot. Make sure it says list 1 and list 2. And then zoom 9. Okay, oops, I've got something in my Y equals. So let me go ahead and delete that. And I'm going to turn off my plot number 2 because I've got that on. I don't need that plot on. Okay, there we go. So now zoom 9. So there are the dots. Okay, there are the dots. Now I can't tell that I put that extra dot 3, 7 in there. However, the correlation will be, it might or might not change. Let's find out. So stat calculate number 8. So I added that 3, 7 in. Did it change the correlation? Yes, it did. The correlation is now 0.73. Okay, so it made it a little bit stronger. So 0.73. So adding that dot in made it a little bit stronger. Okay, now what I'm going to do is I'm going to take out that dot, and now I'm going to put in the 2, 6. Okay, so let's see, I'll do that one in red, the 2, 6. So over 2 up 6, that's right there in the center. All right, so what I'm going to do now is I'm going to go ahead and I'm going to replace the 3, 7 that I added, and I'm going to make that a 2 and a 6. And now I'm going to go stat calculate, and I'm going to pick number 8 again, and I'm going to see what happens to the correlation from the original. Oh, it didn't change because that's rounded. So 0.71, 0.71. So adding that dot in did not change the correlation. Think about it. It's right in the center of all those dots. All right, let me get rid of that one, and let's move to a different color. So the next one is 10, 0. Over 10, up 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 0. Ooh, obviously that's going to make it weaker. Okay, that's definitely going to be weaker. Let's find out. So again, I'm going to go here, and I'm going to change that last one, the 2, 6, to a 10, 0. Please play with this. Practice this. You've got to get good with the calculator, folks, in order to do things in a timely manner. All right, so now let's see. Stat calculate, again, number 8. And, wow, it made it negative. Look at that. It's now negative point. Okay, it's still kind of strong, but it's strong in the other direction. That's weird, but that's what happens. That dot, obviously an outlier, made it so that it actually changed, the correlation changed direction, because now it thinks it's negative. So that means this one is the negative 0.70. Okay, let me take that one out and let's take a look at the next dot. So the next one, let's see, what color haven't I used yet? Let's use blue. All right, the next one I'm going to put in is the 10-6. So over 10 up 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. So that's going to be right there. Okay, well, obviously, all right, well, let's see what happens. I don't want to say obviously because it may not be obvious. So again, I'm going to go in and I'm going to change that dot, that 10-0 to say 10-6. Stat calculate number 8. So let's see. 0.21 or 0.22. 0.22, that would be this one. 0.22. All right, let's see. We got 2 left, folks. Nope, 3 left. So the next one is 1014. 1014. Well, 1014, okay, just to save a little bit of time here, ladies and gentlemen. 1014, let's see where that's going to be. Over 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, think about this, folks. Okay, I don't want to take more time with the calculator, but 1014, that's definitely going to make it stronger, right? So that has to be this one, 0.96. Okay, the 100 0, whoa, 100 over 100 up 0. Okay, well, think about this, folks. 10-0 was negative 0.70. So 100 0's got to be this one. Okay, this is how you got to kind of understand and get to know correlation. So you can make these judgment calls without necessarily having to put everything in the calculator. And then the 10-6 over, or 106 over 100 up 6, okay, that should be that one. Okay, check them out. If I'm wrong, let me know I'm wrong and I'll give you bonus points. Okay, so check them out. I don't think I'm wrong. At least I hope I'm not. All right, a couple more things. So again, here's a problem. I'm not going to take the time to do it, but I'm going to look at it. Okay, coffee is a leading export for several developing countries. When coffee prices are high, farmers often clear forests to plant more coffee trees. Here are data on the prices paid to coffee growers in Indonesia and the rate of deforestation, which they talked about in the news this year, in a national park that lies in a coffee producing region for 5 years. Okay, so what is the correlation? Is it positive or negative? So you'd put this in list number 1. You'd put this in list number 2. Go ahead and try it. What is the correlation? That means is it positive or negative? And what is the correlation? And then is the correlation very strong, strong, mildly strong, weak, or very weak? Okay, so let me give you some guidance on that. Okay, and we're not going to do that. Here's another problem, but I'm already over 30 minutes. Here's another problem. You would put this in list 1. You'd put this in list 2. And then you'd figure it out. But let me give you some guidance with very strong and so on. So very strong, ladies and gentlemen, is basically anything in positive or negative in the 0.80s to into the 90s, and 1 obviously, okay? A strong correlation, we can say anything from like the 0.60s positive or negative to up to 0.79, okay? And then the next thing is mildly strong. So mildly strong, we could go anything like 0.40 to 0.59. Okay, and then weak would be positive or negative like 0.20 up to 0.39. And then obviously very weak is the rest. Okay, so 0 up to 0.19. So that's kind of the breakdown for the very strong, strong, mildly strong, weak, very weak. Just break it down by the 20s, basically. All right, and one more thing that we need to look at for this, or a few things, sorry. So again, see page 179 in your book, Categorical Variables. Here's a scatter plot. Now within the scatter plot, there is actually a categorical section to it. Okay, remember categorical is not numerical. So if you look at these blue dots, so we got all of these dots, and obviously it's a negative correlation, and I believe this is dealing with the SAT math scores by region. Now they broke it down. The blue dots are the East Coast. Okay, so within a scatter plot, you can actually make categories and use different colors or different symbols for different things. So here they used the East region and put those in blue dots so we can see where they are within that scatter plot. Okay, again, this is in your book. Please read that example. Here's another scatter plot. Obviously it's positive, but here's a caution, ladies and gentlemen. Look at this scatter plot and see it. Now look at this one. It's the same scatter plot. Look at the scale. 0, 50, 100, 150, 200, 50, 100, 150, 200, 60, 80, 100, 120. Okay, so looks can be deceiving. Okay, so be careful. You may look at this one and then look at this one and go, oh, well, that one's stronger. No, it's not. Okay, it's the same, but the scale is different. So be aware that looks could be deceiving. All right, and please, 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 please look at all of the cautions on page 192 and 193. All right, folks, it's almost been 40 minutes. I hope you were able to get through that fairly easily. Please practice with that calculator. All right, we'll see you soon. Bye.